Lesson 66, we're talking about solving polynomial equations. This is factoring just like we know how to do it. Okay, it's just going to be working with a little bit more advanced trinomials, maybe a few with 4 terms and some higher degrees. But at the end of the day, it's still the same process. It's everything that you know. Let's start with example 1a. 2x to the 4th minus 10x cubed minus 72x squared equals 0. Notice if we look at these 3 terms, yes, we are dealing with the trinomial. Notice they all have an x in common. And in fact, they got 2 x's in common. So the first thing that we're going to do is let's factor out 2 x's. Now if you notice as well, between the 2, the 10, and the 72, all of those are even, so we can actually factor out a 2 as well. So let's do that. So when we factor out the 2x squared, that leaves us with x squared minus 5x. Factor 2 away from 72, we're left with 36. And again, notice that said equal to 0. That's going to be important. So we factored out the 2x squared, we have a trinomial, and now we're going to do the reverse FOIL to see if we can factor this trinomial. Factors of x squared are just x and x. And now we need to think of factors of 36 that'll get us a difference of 5. If I'm recalling some of the factors of 36, I'm thinking of 9 and 4. And I notice that, hey, the difference between 9 and 4 is 5, so that's good news. I want that 5 to be negative. So the 9 is going to be negative, 4 is going to be positive, and yes, it's going to work out. Once again, if you're not for sure, FOIL and see if you come up with that original trinomial. So at this point in the game, we have the 2x squared, we have the x minus 9, and we got the x plus 4. What we're going to do is take each one of these and set them equal to 0. And then we're going to solve for x. Now the good news is if we go back to the 2x squared, we would divide both sides by 2. So we would get x squared is equal to still 0. And then once again, if we take the square root of both sides, the square root of 0 is just simply 0. So that always works out nicely if you got some 2x squared is equal to 0. X minus 9 is going to be x is equal to 9. X plus 4, x is going to be equal to negative 4. So notice for this particular problem we came up with 3 roots. The solutions are 0, negative 4, and 9. We're going to look at one more example here. We're looking at 4x cubed plus x equals 4x squared. Now if you go back to part A, notice that equation was set equal to 0. We're going to do the exact same thing here. So we got 4x cubed. I'm going to bring the 4x squared over, so minus 4x squared plus x, and now it's set equal to 0. So all I did was simply subtract 4x squared both sides. Okay, let's see if we can factor out that GCF. Notice all the terms have an x, so simple enough. Factor out the x, we get 4x squared minus 4x plus 1. Now this looks like an uncommon trinomial, but if we look at 4x squared minus 4x plus 1, this does indeed factor if we do the reverse FOIL. Factors of 4x squared, I always like to try 2x and 2x first. Now the good news is, to eliminate some combinations, the only factors of 1 are going to be 1 and 1. Now notice the 1 has to be positive, so both of these ones either need to be positive or they both need to be negative. But I notice here that my 4 happens to be negative. So that means that both of those have to be negative as well. We could check it by doing the FOIL. 2x times 2x is 4x squared. 2x times negative 1 is negative 2x. Negative 1 times 2x is negative 2x. Negative 2x and negative 2x gets us negative 4x. And then negative 1 times negative 1 gets us 1, so we're good. Lastly, set all of these equal to 0. So I have x is equal to 0. I have 2x minus 1 is equal to 0. And 2x minus 1 is equal to 0. So this is done. One root, or one solution, is 0. We could add 1 to both sides to get 1. Notice these two are going to be the exact same, so we have x is equal to 1/2, and then x is equal to 1/2 as well. So we really, in this case, have two solutions. We have 0, we also have 1/2. This will be a lead-in to what we call multiplicity here in the next example. Okay, so like we talked about in example 1a, I introduced this idea called multiplicity. Multiplicity, long story short, is just identifying how many times a certain solution appears. Okay, that's all it is how many times is that solution going to pop up. Let's take a look at example 2. In the directions, it tells us to find the roots of the equation. Process as normal. Then it tells us to give the multiplicity of each root. Okay, so let's take a look at it. 5x, or x to the 5th plus 8x to the 4th plus 16x cubed. I notice that I can factor out an x cubed from all the terms, leaving me with x squared plus 8x plus 16. Once again, let's see if we can do the reverse FOIL with this. Factors of 16 look like they're going to be 4 and 4. Everything's positive. 4 and 4 will get me 8 as well. So we're good. So once again, x cubed is equal to 0. Therefore, x is going to be 0. And then x plus 4 is equal to 0. X plus 4 is equal to 0. So x is going to equal -4. And we have the same thing over there on the right with the x equals -4. So we have found the roots of the equation. Okay, we have found them to be 0 and -4. The last part, now we want to give the multiplicity of each root. When we give the multiplicity of each root, really all we're stating is how many times did that root appear. So this can be kind of tricky, but at the same time, it's hopefully after you work with it, it'll be kind of self-explanatory. Notice here we had x to the 3rd. If we go back to our math 8 days, we were told x to the 3rd mean that we had 3 x's. True? So when we give the multiplicity for this particular problem, we say x is equal to 0, and then it's going to have a multiplicity, or with multiplicity, I'm going to abbreviate, of 3. So once again, what does this mean? Well, it's telling us that 0 is a root, but the multiplicity is just indicating, hey, we had this exponent of 3, so that root appeared 3 times. Let's go to the x equals -4. Can you guess what the multiplicity of this one is? Hopefully you guessed 2, and if you did, you guessed correctly. -4. Notice it appeared here. It also appeared right here. So -4 is a root with the multiplicity of 2. And that's all you have to put. We will talk about multiplicity more in depth when I get back, but this is going to be a good start for you guys. Lastly, for example 3, they want us to identify all the real roots. For this particular problem, notice we have 4 terms. We could try factor by grouping, but if we tried it, we would find out that it does not work. Therefore, for this particular problem, I want you to use Desmos. So, on your own, you'll pull up Desmos. You'll type in this equation, x to the 3rd minus 2x squared minus 11x plus 12 is equal to 0. I want you to plug in that equation, and I want you to find, or hopefully you're telling yourselves you need to be looking for the x-intercepts, am I right? Recall the solutions, the roots, the x-intercepts, all of those mean the exact same thing. So if you can find the x-intercepts, those are going to be your answers. You'll probably need a minute or two to get your computers out and get Desmos up and to punch this equation in. So if you need to, pause the video while you do this. Once you look at the graph, once you identify the x-intercepts, hopefully you are finding your roots to be the following: 1, -3, and 4. Regardless of what the graph looks like, this is where it crosses the x-axis. Therefore, the x-intercepts, those are going to be your real roots, and these are going to be your answers. Alright, so I want you to do a few more problems from the lesson practice. I want you to work on A, C, and D. A, you are simply just solving the equation to come up with your roots. And then for C and D, not only are you finding the roots, but you also need to find the multiplicity of each root. Do the best that you can on these, okay? Work together, work with partners, work with groups, okay? Try to come up with your answers, and once you do, you can check your answers with the teacher's edition and see how you did, okay? If you have questions on these, we will always go over these when I get back, but I do want you to try these on your own and get a decent start to it.